welcome back to Maths with Mrs. J. We've been talking about sketching quadratic functions. We know that they sketch in the form of a parabola, and we've talked about the various changes to your basic garden variety parabola that are made depending on whether you have a positive or negative out the front, depending on whether you might be multiplying by a number greater than 1 or less than 1. Greater than 1 makes it steeper, less than 1 makes it less steep. The minus b gives you a shift to the right by b, and a plus c shifts the whole thing up by c. Now, in order to actually use, I guess, this format, we've got to get it into that format. I will say this now, normally if you were presented with a parabola in this format, you probably would not complete the square and put it in that format. I will show you how you would normally deal with that in a minute. But let's just practice our completing the square, because that will get it into this format, and then we can from there tell what the shift has been. When we've completed the square in the past, we've done it when it's been equal to 0. So we've been able to, if there's been a number out the front of the x squared, just literally get rid of it by dividing everything by 2. Here we can't actually get rid of it. We need to leave it written there and do our division like this. So, okay. You may or may not recall when we complete the square, what we're doing is we're aiming to add half of that coefficient squared. That will rig it so that we have made a perfect square here. Now, you can't just add something willy-nilly. You've got to also, in this case, take it away. When we were doing it with an equation equal to 0, we added it to both sides. There isn't really a both sides here because we want to leave the y just as is. So our equivalent of doing the both sides is adding it and then subtracting it. Okay, so what we've got now is 2 outside of. Now we've rigged this to be an x plus 3/4 all squared. Let's just fiddle with this fraction for a minute. We've got minus 5 on 2, minus 9 on 16. So let's put them all over 16. We're going to multiply the 2 by 8, so we're going to multiply that by 8. So we're going to get minus 40 minus 9 all on 16. So minus 49 on 16. Let's just get rid of this from here because we're going to need that space in a minute. And then all we have to do is our normal format, the a can only be outside of your x minus b squared. So we've got to bring that 2 in. So 2x plus 3 on 4 squared minus, when you multiply this by 2, you get 49 on 8. Now, the question didn't say that we needed to actually graph this. They just wanted to say, how has it been shifted? Okay, how has it been shifted? Well, this is a plus 3 on 4. So it's been shifted 3 on 4 to the left. And this is a minus 49 on 8, which is minus what? 6 1/8. So it's been shifted 6 1/8 down. Now, because the turning point of your parabola would normally be at 0, 0, if you have had a translation 3/4 to the left and 6 1/8 down, we actually now know that the turning point of this graph will be at negative 3/4, negative 6 1/8. Once we know where our turning point is, that's a fairly important part of your parabola, and we can use that together with any x and y intercepts that we're able to find to get the shape. Now let me show you how I would normally do this. If you have a parabola that's in the general format y equals ax squared plus bx plus c. So like we had here, all right? So we didn't have it in this format, we had it in this format. The square had not been completed. What you would normally do to draw a sketch of that is you would use x and y intercepts. Now there's a slight fly in the ointment there, but we'll deal with that in a minute. Obviously your y-intercept occurs when x is 0, so y is c. Your x-intercepts would be the solutions to that equation equaling 0. And we know that solutions to that are given by our quadratic formula. And yes, everything does intertwine in maths. That's why you need to master things when you learn them. Now, there could be an issue here. If your discriminant is negative, then you're not going to get any real number roots. And let's just think about that. There could certainly be cases where your parabola is not going to cross your x-axis. It's either completely above or it could be completely below. That's okay. But in cases like that, how on earth are we going to find our turning point? The great thing is that even though these are not real roots, if you go halfway between those roots, so if you add them up and divide by 2, you get that your turning point x value, regardless of whether there were any x-intercepts or not, is going to be at negative b on 2a. So I can, from this equation here, instantly say that my turning point, so our a was 2, our b was 3, so our turning point x value is negative b on 2a, which is negative 3 on 2 times 2, which is 4, and that is what we got, okay? To find the y value, all you've got to do is sub in to your equation. So whatever your x value happened to be, you can substitute that in and work out what the appropriate y value is. So remember that, comes from as a consequence of your quadratic formula, but it can come in very handy.